Hey guys, and welcome back to the. I've got to restart this. No, I'm not going to restart it. It's too much effort. Welcome back to day 2 of thermochemistry. We're on trend 2 out of 4. Ionic radii. This should be a small video today, short video. I've pulled a sneaky on you. I'm recording this literally an hour after I recorded my first one. But ionic radii. This is if ions get bigger or smaller as they gain and lose electrons. So, let's have a look at this. Let's see what's happening here. Let's try and figure this one out. We've got lithium here, and it's 152 pictometers. Pictometers is smaller than millimeters, and smaller than micrometers, but bigger than nanometers. So this is 10 to the negative 9 meters. As you can see, as we go to lithium plus, it loses an electron, and it gets smaller. Same thing for this one. Sodium loses an electron and gets smaller. Magnesium loses 2 electrons and gets smaller. Beryllium loses 2 electrons and gets smaller. How about fluorine? Fluorine gains an electron and gets bigger. And chlorine gains an electron and gets bigger. So let's try and understand what's happening here. Lithium, of course, is number 3 on the periodic table, meaning it's got 2 electrons in its inner shell and 1 electron in its valence shell, its outer shell. As we lose an electron, we're not just losing 1 electron, we're also losing a whole shell of electrons. Meaning lithium is big because it's got 1 electron in its outermost shell. When it loses that electron, we're just going down, we're losing a whole shell of electrons, going down to what's called the core electrons. And it's getting that noble gas electron configuration. So when cations are formed, because cations are positive, we're losing a whole shell of electrons, making the ion way smaller. What about here? When fluorine gains an electron, we're not gaining an electron shell, because this has got 7 electrons in its valence shell, same with chlorine. This is going to 8 electrons, so what's happening here? Well, electrons repel each other. So as we add in another electron to the shell, we're not adding in another proton to contract it at all, because if we add another proton into it, it would have more positive charge in the nucleus, meaning the electrons are now more attracted to the nucleus, making it smaller. So there's not another positive charge, the positive charges stay the same. We've added another electron, which means there is now more electron-electron repulsion, meaning they're now more spread out, hence they get bigger. These are some notes for you to pause the video and write in your book. I'm just going to read through the notes now. Cations, they lose their valence electrons, which is their outer shell, so the ionic radii is smaller than the atomic radii. Anions gain electrons to fill their valence shell. More electrons means more repulsion between electrons, making the ionic radii larger. Don't write this down. Don't write that last part down. That's not going to make sense right now. So let's try, you should have written this down in your notes. Let's try this one. We've got 114, 197, and 203 pictometers. We're going to match the radius to the atom or ion. So this is probably a common exam question. If you can match them up, they'll be achieved. If you can justify this, this will probably be a merit. So let's try and figure this out. Let's have a look between calcium and potassium right now. Let's have a look at it here. You're going to have a periodic table with you, so you don't need to do what I've just done. But you can see that calcium is right next to potassium, and because it's in the same group, but it's slightly further along, calcium is smaller than potassium. Okay? That's because same number of shells, but calcium's got that one extra proton. Yeah, proton in it, making it smaller because it has more nuclear charge. It has a lot bigger attraction towards the electrons, making them hang closer in. So we know that calcium's going to be smaller. Calcium's going to be smaller than potassium. And as we saw before, when calcium becomes an ion, it gets smaller, because cations lose their valence electrons. The cation is smaller, meaning our smallest one is going to be this one. So this, 144 pictometers, is likely going to be our calcium 2+. Now, these two, remember, calcium is going to be smaller than potassium, so this is likely to be our calcium, and the biggest one is our, so this one's going to be our calcium, and our largest one's going to be our potassium. Cool. So that's actually everything on trend 2 out of 4. So we're halfway through the first third of this topic. Wow, that's gone fast. Here are some extra, there's a fun Kahoot. Unfortunately, it's really difficult to do Kahoots via distance learning. Oh well. Extra videos you can watch at home. Optional if you don't really understand what we've just done. I'm going to put these on the Google Classroom for you to do an optional watch. Alright, thanks guys.